My name is Dr. Janardhana Rao, working in Aeronautical Engineering College. I am associate professor. Today my topic is operating systems and operating system functionalities. We'll see what is operating system. So we cover these topics in this module: operating system objectives and functions, computer system architecture, operating system structures, operating system operations, evaluation of operating systems, and what is types of operating system: batch and multi-programmed, time sharing, personal computer, parallel distributed systems, real-time operating systems, and special purpose systems, operating system services, user operating systems, interface, system calls, and all we discuss one by one. So after completion of this course, so one will learn these are the outcomes of this topics. Distribute different architecture using design of modern operating systems. Solve problems related to process scheduling, synchronization, and deadlock handling in IARE and multi-processing systems. Choose memory allocation algorithms for effective utilization of resources. Select various space replacement algorithms applied for allocation of frames. Make use of different file allocation disk scheduling algorithms applied for efficient utilization of storage. Outline mechanisms used in protection of resources in real-time environment. So, rather you can say the operating system is everything for the system. So, whatever system or the user wants from the system, that will be done by the operating system. So, you can say rather operating system is everything for the system. Operating system objectives and functions. An operating system acts as a communication bridge that is interface between the user and the computer hardware. Operating system is a software. It is a program that acts as an intermediary user of computer and hardware. The hardware is, if you look at a system, there are two basic components. One is hardware and software. The software, rather you can say, your software is your OS. The OS user will interface to the hardware through the software only. The software is your OS. So this is an example. You can see this is user, and this is hardware. So user can interface directly, cannot touch the hardware. So only the OS will make use of or help the user to get the job done through the hardware. So if we look at this definition, the operating system objects and functions. In the computer system, basically it comprises of the hardware and software. Hardware can only understand machine code. So that is zeros and ones. That is hardware basically. Operating on your hardware is microprocessor, and different chips are mounted on the motherboard. So hardware can only understand machine, that is machine code. In the hardware, the microprocessor will have only arithmetic logic unit circuits, and these circuits can understand only zeros and ones. So which doesn't make any sense of native user. We need a system which can act as an intermediary and manage all the processes and resources present in the system. It is a program that controls the execution of the program. So that operating system is software which can understand user requirement and get the job done through the hardware. So that directly what it means, the user cannot interact directly with the hardware. So there is the intermediate thing is there. That is our operating system, which can understand the user requirement and get the job done through the hardware. So that is objectives of operating system. The purpose of operating system is to provide a platform on which a user can execute programs in a convenient and efficient manner. An operating system is a piece of software that manages the allocation of computer hardware. So it means the operating system is a piece of software. So as you can say, this is our operating system, and inside this operating system there are number of programs. Different programs are there. These programs are .exe files. .exe file. It means that the operating system is full of bunch of programs. In this one, are .exe files only, or .exe file or .dll files. The DLL files, dynamic link library files are there. These programs, some of the programs will do some job for the user. So suppose we write a program that is either Java program or C program or Python program. This program to executed by the OS through your hardware, the microprocessor. So what it is. So this is basically OS is a program, but it is in the compiled program that is .exe files. All these files keep on adding by the developers, and once it becomes sufficient or fulfilled, then this OS will be installed in the software system, and these programs will help the user and to get the job done through the hardware. That's what is the main meaning. So your OS is getting the job done by the hardware means. So it is in the form of zeros and ones basically. So it can understand and it can interface with the hardware very easily. So the coordination of the hardware must be appropriate to ensure the correct working of the computer system and prevent user programs. From interfacing with the proper working of the system, it is responsible for the execution of all processes. So resources allocation, CPU management, file management, and memory other tasks. It means that the computer so whatever software we install in the system, the software is responsible for everything whatever user wants. It will do everything for the whatever user wants. It will get the job done by the hardware. So all these programs are in the OS. These programs in the shape of .exe files. So this is, you see, the operating system object-oriented functions. So if you look at this one, in this one, your hardware, operating system, application software. So system software, databases, internet, browsers. These are all programs only. These are all this is all program software only. Basically, hardware is the hardware. Your hardware. This is your hardware, and this is your operating system. And this left of application programs, application software, system browsers, computer games, system software. All these are the softwares only, except your hardware. So user will interface to the hardware through your operating systems. That's what the main meaning is. So this is the basic section of, you can say, the operating system objectives and functions. So the operating system objective function, if you look at further, like a computer system consists of users, that is people, what we, and application programs. If you look at this earlier diagram, if you look at this diagram elaborately, so the structure of a computer system is like this. The computer system consists of users, that is we, the people, and application programs. That programs come that if you're writing, if you're executing any Java program or Python program, we require compilers software. That also we have to install in this system. And databases, games, video players, browsers, there are application programs, specific application programs. Next, system programs. System programs means system will have the core programs which can directly interface or interact with the hardware. That we call system programs. Later on, operating system. Operating system the system programs is part of the operating system only, but that is core. So interface between the user. This is a special program which acts as an interface between user and hardware. So hardware, we got hardware in the system. Hardware is CPU, disks, hard disk, memory, etc. So if you look at this basic computer system, these are the fundamentals or components. So operating system objectives and functions. It makes a computer more suitable to use, efficiency. It provides the computer system resources, efficiency, and in easy to use format. So that is the basic fundamental thing what we require. The operating system is an interface between the user and the hardware. Ability to develop, it should be built in such a way that it permits the efficient development, testing, and installation of new systems function with interfacing with the service. So the operating system is nowhere going to stop. It is going to keep on developing by the developers every day. We're getting upgradation of the operating systems. Initially, we got Windows After that one, Windows XP. After that, like this, keep on adding the features for what the user wants day by day. So that's is able to we have to keep on developing or upgrading the operating systems day by day. So that's what. So at an upper level of the computer architecture, a computer is supposed to have a processor, memory, and some I/O components with one or more equal quantities of each type. These components are interrelated and connected in a way to achieve the major function of the computer, which is to execute programs. So there are four key structural elements of computer. So these are, so if you look at this one, if you look at the motherboard, and we have the processor, that is your microprocessor, and this is your microprocessor, and the main memory, that is your RAM slots, RAM slots in the hard disk, and your RAM, or this is your ROM, and the hard disk, microprocessor, RAM. So if you look at this one motherboard, you will find the different components like this. So if you look at the one of the more major component element is my processor. It controls the processes within the computer and carries out its data processing functions. When there is only one processor available, it is in the combination of termed as the central processing unit, which you must be familiar with that. So if you open the motherboard, you will find the center part. You can say this is your CPU. This is CPU or central processing unit. So what is inside this one? We will have ALU and some temporary buffers, buffer registers for keeping the results. So this is our main processor. It will only execute the programs. What it means by executing the program means whatever program you write, either Java, C, or Python. So this program, each line is one instruction only. This program will be executed by the processor, this microprocessor. So what I mean? So this is it controls the processes within the computer and carries out its data processing functions. When there is only one processor available, it is in the combination of termed as central processing. It actually, this is a central processing. By our microprocessor is a central processing unit. So that is the thing what I want to say. So other than this microprocessor, we got some other components in the motherboard, that is your main memory. Main memory is nothing but your RAM. So it stores data and programs within it. The memory is typically volatile. Volatile means the moment you switch off without saving the program, whatever program you write, that is in your RAM only. That is in the RAM only. This is your RAM slot or RAM card. So whatever you are writing now, that program is in the RAM. That is in the RAM only. You can see on the screen. Whatever you are looking at the screen, that is in the RAM. Once it is not in the RAM, means you cannot see anything on the screen. So whatever you are watching on the screen, that is in the RAM. So after this one, if you write this program, so you go for saving in the hard disk. That will be saved in the hard disk or C drive or D drive. That will be saved there. So it means if you don't save in the hard disk, then you switch off the system. So automatically it will vanish. You cannot get it back again. So this is called volatile memory. Volatile memory. So this is primary memory. Why you call it main memory or primary means it is must. RAM is must. If you don't have RAM in the system, your system will not work. So you cannot see anything on the screen. You will get some buzzing sound. So it stores data and programs within it. This memory is typically volatile and it is also called primary memory. This is because when the computer is shut down, the contents of that are within the memory gets lost. In contrast, the contents of the disk memory are kept whole, or even the computer system is turned off, which we call as a shutting down an operating system or computer. The main memory is also termed as real memory. So this is real memory means what we are seeing on the screen, that is available in the somewhere in the sense that RAM only. So we call it as main memory component. So this is main memory. So IO modules is like your keyboard and all. So here, this moves the data within a computer to its peripheral external environment. The external environment supposed to have a variety of devices, including secondary memory devices, pen drives, CDs, communication equipment such as LAN, cable, terminals, etc. Then after that, you will see the system bus. It provides communication between processors, main memory, and I/O modules. If you open motherboard, you will find different components and a ribbon-like arrangement from one IC to another IC, ribbon-like. In this ribbon, you will find number of lines. These are not lines; these are the wires. So going from one IC to another IC, like this. So this is we call bus, because the signal is traveling on the cable. There are 7 cables, in the sense 7 wires are, 8 wires are there. So at a time, 8 signals will be traveling parallelly from one IC to another IC. So it provides communication between processors, main memory, and I/O modules. So that's what system bus. We use it for the communication purpose. Next, we'll see the operating system object function. It is by extension of that one. So if you look at this one, users, application programs, utilities. If you look at this one, so what we discussed so far, we are the users, and interfacing with the operating system. Application programs will be there, utilities will be there, machine language, micro programming, and CPU memory. So these many components are there before touching to your hardware. So suppose if you connect any device, that is your printer, your mouse. So operating system as it is there. Apart from the operating system, there will be a specific program for that application for that device. That's called, we got application programs. So these are the hardwares. This is hardwares, and these are the hardwares, and these are the this is user level, and this is our operating system level. See, if you look at this one, there are user, system, and hardware. So we have to understand these basic components, how the operating system will interface with your hardware. So user can interface with the hardware through the system, that is our operating systems. Okay. So this is what are the functions of operating system? If you look at this one, security, it will provide security. Security means in the operating system itself, we will include security concept, that your firewalls and everything comes under this one. Control over system performance, job accounting, error detecting aids, coordination between other softwares and users, because operating system is software. Other than the software operating system, there are other software also there, that is device drivers. So once you connect one device to the system, that is your pen drive or any mouse or any joystick and all, for that one, there is a specific software will be there. You have to install that software in the system, that is automatically device drivers will interface your device with the operating system. So there are some programs well in advance, predefined software is there in the operating system that will recognize your device drivers, so that your device is recognized by the hardware. That's what the sequence. So that is memory management is there, processor management, device management, file management. So if you look at these functions, what user required from the user, everything is done by your OS only. See here, it is provided security, control over the system performance, job accounting, error detecting aids, coordination between other softwares and users, memory management. So all these things will be done by OS only. And actually, OS is not doing. Inside the OS, there are number of programs. These programs, they will do some application, and some programs are there. These programs will do memory management. Some programs are there. This will do your security. And this what I insist this one. What is inside the somebody should understand what is inside the OS. Inside the OS, there are number of programs. These programs are .exe file, so that these programs will only help the user to get the job done through the hardware. Hardware cannot understand what user want. Only OS OS can understand. Inside the OS, there are programs. These programs can understand what user is typing. So that's what I insist is. So inside the OS, there are number of programs. These programs will help the user to get the job done what user want. So see, these are security, control over system performance. So what is security? By means of password and similar other techniques, it prevents unauthorized access to the programs and data. This is simple security. That is password and authentication, and control over system performance. Recording delays between requests for a service and response from a system. It will coordinate, synchronize, and job accounting, keeping track of time and resources used with various jobs and users. Because the OS will keep a track, it will make a record for everything. What is happening in the system, time to time, everything is saved somewhere in the hard disk one by the OS programs. So error detecting aids, production of dumps, traces, error messages, and other debugging and error detecting aids, and coordination between the softwares, other use. So inside this, apart from the OS, there are other softwares are there. But that is what coordination and assignment of compilers, interpreters, assemblers, and other softwares to the users used by the computers. Because when you want to do any Java programming, we will install JDK. Inside the JDK also is software. So our OS is a software. So OS will coordinate with the JDK, and what Java program you are writing, the Java program will be executed. It will understand. OS will get the job done because you wrote a Java program. This is all software, and our OS also a software. So software will help the software to get the job done. So what is that one? That is that your OS will understand the program and get the job done. That's what. So provides facility to create modification programs and data files using an editor. So once you are doing Windows, once you are writing a Word file, you are writing a Word file. So that is editor. What is an editor? So the OS will provide this facility to the user when you are typing some Word file. So OS only provide this one. And OS after writing this one again, once you want to save, and the OS will only save the file in the hard disk somewhere. So that's what OS will do. So access to compiler translating user program for higher language. So once you write a Java program, so once you write a program, this is line 1, line 2, line 3, like this. Once you compile this one, once you compile this program, the program will convert into binary code, and this binary code will be saved in the hard disk. Hard disk like this, it will be saved in the hard disk. So what I want to say, ultimately, it will save us in the hard disk. So provides a loader program to move a compiled program or code to the computer's memory for execution. Provides routines that handle the details of IO programming. So basically, OS is a program, but OS, that programs are only helping the user programs to execute, save, and run the program, provide routines, and everything done by way of OS. IO system management. The module that keeps track of the status of device is called the IO traffic controller. Each IO device has device handler that resides in a separate process associated with that device. So this is IO system management. So as I told earlier, once you are connecting a device to your system, so your system will not recognize that device unless you install your device drivers. Okay, so that's what IO traffic controller. See, so once you are connecting a keyboard or mouse, for that one there will be one device drivers will be there. The device drivers will recognize your device and coordinate with your OS. So that will be done by your OS only. A memory management component that includes buffering, caching, and spooling. A general device driver interface. Again, your Above the memory management. What is memory management? Whatever you file you type on your screen or program. So once you want to save it, what it does, it will convert into binary form or compiling. After when you are compiling, you are getting the binary form, and this file is saved in the hard disk. Till that time, it is in the RAM only. This is in the RAM only. Once you compile, after compile, if you save it in the hard disk, that will be converted. This will transfer to your hard disk. So this is called, where is a memory space available in the hard disk, and that also OS will recognize it and identify the suitable place for this program, and then it will save in this memory. That is what I want to say, memory management. So for everything, we got a programs in the OS, and these programs only manipulate your data in the hard disk or RAM. So data set is nothing but how effectively we can store our data in the RAM or hard disk. So these are the softwares assembler. The input to assembler is an assembly language program. The output is an object program plus information that enables the loader to prepare the object program for execution. At one time, our computer program had at its lowest disposal a basic machine that interpreted through the hardware certain fundamental instructions. This computer by writing a series of zeros and ones. That's what machine language, what we are telling discuss. So compiler, as we discussed, compiler. A compiler is a software that is system programming. So whatever program you write, the high level language examples, Python, C, Java, and these are all called high level languages. The compiler is a program that accepts source code in a high level language and produces a corresponding object program. What we're discussing, object programming. An interpreter is a program that appears to execute the source program as if it was machine language. So ultimately, what it does, these are all softwares, system programmings, are available in the system apart from the OS, and they will coordinate with the OS. And if you write a Java program, the Java program will be converted into a bytecode. The bytecode is 16-bit code, and ultimately it will be converted to your 0 1s machine language. The machine can understand and execute. Ultimately, your OS will monitor what is going on in the system. So that's what I want to say. So the same name, Python COBOL, is often used to designate both compiler and its associate languages. So if you want to execute Java programs, you must have Java compiler. Similarly, you want to execute the C programs, you must have Turbo C. In Python, you're writing a Python programs, you write a Python, you have to install the Python or notebook, Jupyter notebook. So what I want to say, the corresponding compiler is still there, the corresponding assembler will be there, and they will coordinate with your OS. Then ultimately OS will monitor what is happening in the system. This is what I want to say. Loader. A loader is a routine that loads the object program, prepares it for execution. So ultimately, once you save, you write a program and you compile it. The compiler compile it, and it will be loaded in the hard disk. Saved there. Once it is saved there, so after saving, once you want, it will not be in the RAM no more now, in the hard disk now. So when you want to execute this program, again, this program will be loaded into the RAM. Again, it will be brought into RAM. So now the OS will do the all magic. It will get your file from hard disk to RAM, now RAM to your microprocessor for execution. So this is called loader. Is a program that places program into main memory and prepares for execution. In a simple loading scheme, the assembler outputs the machine language translation of the program and secondary device and loads place into memory. So this is simple. Once you write a program in the RAM, that will be in the RAM. Once you save it, it goes to hard disk. That is saved in the hard disk now. So even you delete, if you switch off the system, Whatever program you wrote in the RAM, that is vanished now. That is no more. No more. So there will be no more now. There is no more in the RAM. So that program is in the hard disk now. So when you want to execute this program, and this will be again brought, that is loads back to your RAM. Now RAM only, it comes to your microprocessor. So these programs, all these programs, what is going on here, that will be, that programs are in the your OS only. These programs only manipulate what to do, what not to do, how to do, and all those things. So everything is monitored by your OS only in coordination with the other softwares which are here loading for the particular program or language. That's what. So this is a loader, and the loader places into the memory the machine language version of the user program and transfers control to it. Since the loader program is much smaller than the assembler, this makes more core value available for the user programs. So these are all programs, so software only. Okay. The computer system structure consists of, we'll discuss now computer system architecture. So as we know, there are different components in the computer. They were input, output, or a motherboard. In the motherboard, you got a microprocessor, and all these things we'll discuss one by one. How they interface to each other, and ultimately whatever OS is coordinating all the work, what is going on there. The computer system section consists of interrupt mechanism for I/O devices, memory unit to run the programs, memory to protection, and disk storage to save programs and data files. The modern general purpose computers have CPU and device controllers for devices such as disk, audio devices, and video display device connected to common system. As I explained previously, suppose this is your microprocessor, this is your central processing unit CPU, and once you are connecting any device to your system, CPU cannot understand, OS also cannot understand. To make the interfacing with the OS, we install device drivers. These are software for your concerned device. So this is a device we are connecting mouse or wireless mouse. So this is another software we are downloading in this system, that is your device drivers. So they will interface with the OS. Ultimately, the CPU can recognize this. CPU can recognize what device is connected, how it works. Like this is called, we call in the motherboard itself. We got different controllers for the keyboard. We have got another IC, the chip, like CPU. Like CPU is a IVLS chip only. Like this, for everything we got one different ICs. You can say controllers. It is a keyboard controller. This is a hard disk controller, disk controller. These are the hardwares concept. So that the device drivers will interface with this device controllers, and OS will make interface this one. So each controller is a specific device only, and it has a local buffer. The CPU and device controllers can run concurrently and complete the memory. A memory controller synchronizes access to shared memories. What I want to say, for every operation there will be a control IC. Like CPU is a main IC, and apart from this, there are a number of ICs on the motherboard. Each IC will have its own role of function. That for keyboard there will be keyboard controller, and your hard disk there will be hard disk controller. Disk controller will be there. So these all are interfaced with the CPU, and OS will be monitoring this one, coordinating. Ultimately, your OS is the one who is coordinating all the functions in the system. Next, we'll go. This is your computer system architecture. So as I explained now, your CPU is one. Your CPU is the main VLSI chip. This is VLSI chip. Others also VLSI, but the size is bigger because it is having more circuits, binary circuits inside this one. Your disk driver and your mouse, your all inputs, and your memory, USB controller, disk controller. Once you are connecting hard disk and disk controller will be there in the on the motherboard. So similarly, USB controller. Once you're connecting a keyboard and mouse, and they're connected to USB controller, this is IC. This is IC. This is also IC, and this is also IC, and we call device controllers. You can say this is also this display adapter for monitor. This is also IC. These are the hardwares. These are hardware ICs, and these hardware ICs. CPU is the main IC. You can say VLSA chip. This is VLSA chip. This is also chip only. What is IC? Integrated chip. So these chips are interfaced to these devices. So what I want to say, this is memory. All are connected to memory. This is the connection to the system buses. You can say system bus is nothing but a wire connected for communication from one IC to another IC. We got the communication ribbons. You can say ribbon type arrangement is there. We call it a bus. So system bus. So this is a complete computer system architecture, and we got another one. A computer system can be organized in a number of different ways, which can categorize it roughly according to the number of general purpose processors used. Sometimes in some other systems, we got for mathematics, we got another processor. For executing the instructions, we got CPU, that is 8086 and 8087 like that. So this is the thing. Instruction execution cycle, data movement cycle. If you look at this diagram, instruction executing is there, and execution cycle and data movement from CPU to memory and data memory. This is what I want to say. So we got single process system and multi-process system. So in earlier days, we used to have single processor, means on the motherboard we got one microprocessor. This is our single processor system. Nowadays we have got on the same place, we got number of processors placed on the same place. So i3, i7, i5, different processors are there. Nowadays we are getting this one. So once we discuss this single processor system. So most systems by system single processor systems are single processors. A single processor system, there is only one CPU capable of executing a general purpose instruction set, including instruction from user process. All systems have the special purpose processors as well. They may come in the form of device specific processors such as disk, keyboard, and graphic controllers, and so on mainframes. They may come in from the form of general purpose processors such as IO process that may have different rapidly among the components of the system. So I explained in the earlier slide, this one, if you look at this one, so this is a processor, microprocessor, single processor. Apart from this one, we have got some other, this is also processor only. We can count it as a processor because it is also working for certain operations. So we got a processor like this. This is what single processor systems means, like this. So multi-processor system is, as I explained now, in nowadays we are getting the systems i3. i3 means instead of the one microprocessor, we got i3 processors. It means there will be 3 ALUs working parallelly. So what is this is what? This is one ALU, this is one ALU, this is another ALU, 3 ALUs will be there. This is your i3 processor. So if it is i5 means there will be 5 processors on the same computer. So what is the main advantage of this multi-processor system? What are the advantages? There are certain advantages in the multi-processor system. If you look at this one, you can see by increasing the number of processors, one can expect to get work done in the less time. Suppose if only single processor is there, to execute the 100 lines of the program, it takes maybe 2 milliseconds. 2 milliseconds. So 2 milliseconds. Suppose if I install 3 microprocessors, same 100 lines program can be executed within 0.5, like this, 0.5 milliseconds. So this is what the processor increasing, so the job will be done very fast. By increasing the number of processors, one can expect to get more work and done in less time. The speed up ratio with n process is not n, however, rather it is less than n. So when the multiple processors cooperate on a task, a certain amount of overhead is incurred in keeping all these parts are working correctly. So economy scale, multiprocess system can cost less than equivalent multiple single process system, because they can share peripherals, mass storage, and power supplies. If several programs operate on the same set of data, it is cheaper to store those data on one disk and have all processors share them than many computers with the local disk and many copies of the data. So what I want to say, suppose there are multi-processors in the system, and there is a program is shared in the memory. So this program will be for execution. They will share this memory. That's simple. So you can see this increased reliability. See, if one process is not working, so this only one process is there, reliability will be less. So because if this process is not working, your program will not be executed in time. So you don't get output. So if the processors are increasing, if one is not working, other processors are there, so they will take up the job and they will do it. So what is increased reliability will be increased. If functions can be distributed properly among the several processors, then the failure of any processor will not halt the system. Only slow down. Only slow down. If you have 10 processors on one and one fails, then each of the remaining 9 processes can pick up a share of the work of the failed processor, and thus the entire system run only 10% slower rather than the failing altogether. So that is the advantage of your single processor and multiprocessor. The multiprocessor system used today are two types: asymmetric multiprocessing and symmetric multiprocessing. Each processor in asymmetric, each processor is assigned a specific task. And asymmetric multiprocessing, the most common systems using each processor performs all tasks within the operating systems. So clustered systems, we got different architectures of the computer. Clustered systems. Cluster system is a rather type of multiple CPU system. The clustered system differ from multiprocessor system is that they are composed of two or more individual systems coupled together. So instead of one system, we have got a number of processes. This is a multiprocessor system. The cluster system is system. 2 or 3 systems will be clubbed together. That is called cluster systems. Cluster systems, and cluster computers share storage and are closely linked via local area network or a faster interconnection such as InfiniBand. Clustering is usually used for provide high availability service. Services will continue even if one or more systems in the cluster phase. The clustering can be structured asymmetric or symmetric. So this is cluster. So there will be one storage area is only one network. This is storage area network, and these computers are interconnected like this, and this is the number of computers will be interconnected each other, and they will share this storage memory for execution. So clustered systems can be structured asymmetrically or symmetrically. In asymmetric clustering, one machine is in hot standby mode while the other is running in the applications. The hot host machine can monitor the active server as active server, and if that server fails, the hot standby host becomes the active server. So that is your asymmetric. In symmetric clustering, 2 or more hosts are running applications and are monitoring each other. The structure is obviously more efficient as it was uses also the available hardware. It doesn't require that more than one application be available to run. So this is our computer. So if you look at this one, so far I'm telling CPU. The CPU is nothing but your arithmetic logic unit. This is your arithmetic logic unit, and this is storage unit, your memory, and your output, your control unit, and your input, and this output. If you look at this one, this is a basic architecture of the computer. So the input travels from input to ALU. The computed data travels from ALU to output unit. The data constantly moving from storage unit to ALU and back again, because the stored data is computed and before using stored again. The control unit controls all the other units as well as their data. The operating system is a construct that allows the user programs, user application program to interact with the system hardware. An easy way to do this is create the operating system in parts. Each of these parts should be well defined with clear input-output functions. So we'll go this one. Input unit, output unit, storage unit. As we discussed, the input unit provides data to the computer system from the outside. So basically, it links the external environment with the computer. It takes data from the input devices, converts it into the machine language, and then loads it into the computer system. That is keyboard, mouse, etc. are most common user input devices. Output unit, that is our screen. The output unit to provide the results of the computer process to the users. That is, it links the computer with the external environment. Most of the output data is from the audio or video. Different output devices are there. That is monitors, printers, speakers, headphones. The storage unit is our memory. Storage unit contains many computer components that are used to store data. It is traditionally divided into primary storage, secondary storage. Primary storage is also known as the main memory, and is main memory directly accessible by the CPU. Secondary is externally storage, but not directly accessible by the CPU. So arithmetic logic unit is the main component of your CPU. This is our arithmetic logic. Inside this one, there are arithmetic and logic circuits will be there. These circuits this is only your hardware, which are where our program will be being executed. So all the calculations related to the computer systems are performed by the arithmetic logic unit. It can perform operations like addition, subtraction, multiplication, division, etc. The control unit transfer data from storage unit to the arithmetic logic unit and calculates what need to be done there. The arithmetic logic unit and the control unit together form the central processing unit. So next, control unit. So in the control unit, what is happening? It controls all the other units of the computer system and also known as the central nervous system. It transfers data through the throughput the computer is required, including storage unit to central processing unit and vice versa. The control unit also dedicates how the memory input-output devices, arithmetic logic unit, should behave. So the operating system is a construct that allows the user application programs to interact with the system hardware. Since the operating system is such a complex structure, it should be created with the utmost care or can be modified easily. An easy way to do this is to create operating system in parts. Each of these parts should be well defined with a clear input-output functions. So this is operating system structure. If you look at this one, application programs, system programs, application programs, system programs, and your MS-DOS device drivers, ROM BIOS device drivers, your MS-DOS activities. So if you look at this one, so your application program and your system programs and your DOS device drivers and ROM BIOS device. The common example of this MS-DOS architecture. So this is got your layered structure. Okay. One of the most important aspect of the operating system is ability to multi-program. A computer system is basically a machine that simplifies complicated tasks. A single program cannot do that one. In general, keep either the CPU or IO device busy at all times. So both cannot work at a time. So single users frequently have multi-program running. Multi-program increases CPU utilization by organizing jobs so that CPU always has one to execute. So your CPU will be always busy with the execution of the program. Program is nothing but a process or a job. So whatever program you write in Java or Python, each one is instruction. So once it comes for execution in the CPU, this is nothing but a job 1, job 2, job 3, job 4 like this. So we will continue this class next.
Like, share and subscribe. Hit the bell icon for more updates.